Hello and welcome. My name is Mr. J.M. Kimani. Welcome to Lesson 3, Decision Theory. Lesson 3 is on decision trees as part of the environment of risk. Like I told you in our lesson 2, that there are some questions cannot be modeled using a table, but can be not modeled using a tree diagram. Now, a tree diagram will be having these major symbols. So we'll have symbols used. We have these two major symbols. We have the box and we have the circle. So the box, this is representing decision node, and this represents the event node. Now, the decision node is used when you are making choices. So here is when making choices, that you select one choice out of the many. But the event node is used when you are determining the outcome. So this is for the expected outcome. So here you don't make a decision, but you look at the outcome of all the possible states. Now we have, when you have decisions or alternative decisions, we use a box, and we have the what you call the states of nature or the conditions. We normally use these event nodes. Now, decision tree diagram is diagrammatically represented decision process that we are going to put it on a diagram, and then we try to follow the same procedures. Now, there are some steps involved here. So steps in making decision using a tree diagram. The first step is defining the problem, just like we did in the other one. So define the problem. Also now, the second step is structure the tree diagram. Now having a logical flow with these decision node and the event node. That is structuring the decision tree. Also number 3 is assigning the probabilities to the states of nature. So remember, where we have a circle, we are going to have the outcomes, or either the state of natures, and they are probabilistic in nature. So we'll be having probabilities assigned to each state of nature. Then the next step is estimate the payoffs of each event and action, maybe compared. So if you have a combination of the state of nature and these decision, so you look at the outcome. How much is the outcome for every combination, and therefore it's like the amount we are going to record inside the table, the circle. Then also compute the EMV, which is the expected value, and you select the decision. So if you have 2 or 3 actions, you can select one action based on the expected monetary value, which is the expected value, using the probabilities and the payoffs. So we'll look at that. And also lastly, we select the decision that gives the optimal expected monetary value. So of course, we make choices finally with respect to the one that gives us the highest. But one thing to note is that we normally use, this just to note, we normally use the rollback method. That where we start is where we end. When we start drawing the tree diagram and we proceed up to where we have the payoffs, when you are looking for the solution, we move backwards, determining the expected value, making choices until where we started with the diagram, that we make our final conclusion. That's what we call rollback method. Now, also, there is what we call the Bayes or the Bayesian. You can have the Bayesian approach to probability. Now, Bayesian approach to probability. It happens that we may not want to use what we call the prior analysis. Prior analysis is where we use our own subjective probabilities, our own estimates, our own past experience, that we make decisions concerning such probabilities. Without borrowing information, without obtaining any further information, we just make our conclusions using our own estimated probabilities. We call that one as prior analysis. If you do not want to use the prior analysis, we need to obtain information and we make some credible decisions, then we can use now the pre-prior probability or either the pre-posterior probabilities. Now, this pre-posterior approach is where we acquire information from an expert, we come and revise our probabilities, which are prior, and now we use what we call the revised probability. That process, we call it as Bayes' theorem, and it is what we need to have here. Just to demonstrate, we can have this kind of combination so that you can have the understanding of Bayes, that if this is my prior probability, which of course is subjective in nature, subjective because, like I've told you, it's about our own estimates, is our own past experience, so it is only known and applicable when we are making the decision, but may not be applicable to somebody else. So we call them as prior and subjective. Then you have what you call the conditional probabilities. This is what we call the additional information. When you get information from an expert, you are borrowing information from an expert. That one is in form of a conditional probability. We normally use it as a probability, and therefore we call it as conditional probability, but it is the information you're getting from the expert. So you have the two, what you know and estimated, and the information from the expert. You mix and you use together, you use what you call the Bayes theorem here. Bayes theorem to determine now the revised probability. This is actually the posterior probabilities. Now, this is how we mix it. We use the Bayes theorem to determine the revised probabilities. And we can have the formula this way. So that is, so revised probabilities equals to prior probabilities. You can have it this way. Let me put it here. So that revised probability equals to prior probability times conditional probability. All these we divide by what we call the marginal probability. Now, the prior times the conditional, which is the information. Two probabilities, when you multiply, they give us what we call the joint. So these two, when you multiply them, you get what we call the joint probability. This is giving us joint probability. Meaning, if you have the joint probability that we require, we can divide it directly. We divide the marginal probability. Now, marginal probability is the unconditional probability. In fact, it is the summation of all the conditional probabilities that are related. We can have the probability this way. So assume you have a probability of, so e.g., probability of A given B equals to probability of A multiplied by probability of B given A, you divide by the probability of B. Now look at this. This being my example, it's very simple to understand this. This is the prior probability. Now this is the one that you are revising, since now you have some information. And therefore, as much as it is probability of A, the revised must also be probability of A. So probability of A, given the information that we have gotten. So the information in this case is now this B, and is actually also here. That the information concerning this position. You know, you can get information concerning different positions. Let's say, for example, like you want to produce product A, or either let's talk about maybe projects. Maybe you have project X and project Y. So you can get information for project X and information for project Y. So information for project X is what I'm indicating here. That this is specific information for this action of this project here. And therefore, that's why we are calling it as probability of B given A, because it must be relating to this prior probability. Then, this probability of B, which is the marginal, it is the summation of all the conditional probabilities relating to that maybe prior, which is A. Like now we can say B given A, B given C, B given D, all those. As long as it's B, you add all those conditional probabilities for B, and they give us now this B. Automatically, you know that probability is a proportion which does not exceed 1, meaning the denominator should exceed the numerator. This joint probability here, joint, the two of them, they should give us a probability lesser than the marginal. And that's why I have said that marginal is a collection, meaning it's going to be more than the numerator. Therefore, we'll get a probability. That's how we need to understand the concept of Bayes, or either the Bayesian approach. Now, information is power, and information makes a decision maker change his decision, or either change his maybe thinking and also approach. And therefore, this revision of probability is very important. As a manager, you require to understand position changes. Circumstances, they do change. Take an example. You wanted to produce, like, say, 10,000 units. That was, and you had a possibility of, like, say, 80%. You are confident 80% you're going to produce 10,000 units. Suppose one of the machine breaks down. Suppose a supplier gives information that he will not be able to supply you anymore. Maybe he's become bankrupt, or the material is now not available in the market, is becoming extinct. So if such information you receive, then automatically it would be wise for you to revise your probability, your earlier position of 80% to like a 70, 60, 50%. So it is necessary for you to keep revising your position and your estimates for them to make sense. Otherwise, if you continue with the same 80%, while one of the major machine is broken down, automatically that 80% become useless. So we do not want to have futile exercise. So we would want to keep revising our possibility, our estimates. And that's why we require to understand this Bayesian approach. Now, we are going to use alternative of this. If we are to use alternative, so we can have this Bayesian approach or Bayes theorem with the help of a probability tree diagram. Now, this tree diagram of probabilities is going to assist us understand all these, like the prior, the conditional, the joint, the marginal, like that. For example, we would have maybe the first stage, then second stage, first stage, second stage. Now, this first stage is what we can refer to as prior probability, which is our prior position, what we expect at the beginning. And then you have now what we call the conditional. Conditional probability now is the information you get from the expert. Then we have what we call the joint probability, joint probabilities. Now, when these two are multiplied, the prior times conditional, they give you the joint. So therefore, we can have this. And then for us to understand and show what we call the marginal, we would rather have pairing of these branches, pairing. Instead of these branches ending at the same column, we can pair them so that we can be able to obtain the marginal probability. For example, if this is now where I'm having my X and I'm having my Y here, assuming, then that means this branch must be branch of X, must be branch of X. So they must end at the same position so that you can have our outcome here. And this one you can have the outcome. Such that when you add this, we get the probability. That way. So this is now what we call the marginal probability. You see, now we are able to understand and see the position of each and every probability. Prior probability is always the first stage. The second stage is now the conditional probability, which is the information from the expert also. Then we have the joint probability, which is the prior times conditional multiplied together, you get now this joint. And my joint, I have split them into two parts so that I can be able to show my marginal. Otherwise, if I don't do that, I'll be having the marginal probability of 1, which is a mixture of several maybe aspects here. So we would rather connect the first branch of the conditional and the first branch of the conditional for the other maybe this is the lower branch. We should have them ending at the same point because they are related in a way. These also are related in a way, and therefore we group them that way. When you group them that way, then these two probabilities, they give us 1, and they are what called the marginal probability. Now, when we say that the revised probability is taking the joint divided by the marginal, joint and marginal, then that means you take like this probability here, you divide by this. As simple as that. This is one of my joints, because you can see it's a prior times conditional, I get this joint. I take this joint, I divide by total, which is marginal. This another joint is here, this joint. I again multiply using this. I divide by that. This is joint here. I multiply, or I divide by the total. This is another joint here. I again divide that way. That means I'm going to have like 4 revised probabilities, because I'm having these 4 joint probabilities, and I can divide now by the respective marginal. So the tree diagram, what we call probability tree diagram, assists us so much not to actually cram this formula, and where we have some less understanding concerning these formula, we can use this tree diagram and we are able to understand the whole concept. That is why the tree diagram is important. So we'll be using this tree diagram and be able to answer our question. That's all. So this is the introductory part concerning the decision theory, decision tree, so that now you're able to draw or have a question. We draw the diagram and we make our conclusion. So illustration. The illustration reads that Watt Limited is trying to decide whether or not to drill for oil in a particular site in northeastern Kenya. The chief engineer has assessed the probabilities that there will be oil as follows based on the past experience. That probability of oil is 0.2, probability of no oil is 0.8. It is possible for Watt Limited to hire a firm of international consultants to carry out a complete survey of the site. Watt Limited has used the firm many times before and has made the following estimates. The first one is, if there is really oil, then there is 95% chance that the report will be favorable. The second one is, if there is no oil, then there is only a 10% chance that the report will indicate that there is oil. Then the following additional information is also provided. 1, the cost of drilling is shillings 10 million. The value of benefit if oil is found is shillings 70 million, and the cost of obtaining information is shillings 3 million required. A, advise the company on whether to acquire additional information from the consultants, and B, compute the value of perfect information. End of question. Now that is a simple illustration, but with a lot in it, because it will carry with it the division of probabilities. It also have a diagram which is going to be to expose us to how a diagram should be drawn. That is why the question is important. It's so small, yes, but with a lot. Now that question, we need to first of all come up with a sketch of a diagram and be able to maybe see the flow. The hint is that whenever you are drawing a tree diagram or addition diagram, you are supposed to have some logical sense of the diagram. For example, there is no way you would expect that you decide whether to, let's say, like you even have oil. You're imagining you're having oil and then no oil. And then with the oil, you decide whether to drill. For example, look at this. At you drill, no drill. It's not possible. How can you drill after you have oil? How did you even get oil in the first place? So this tells you that there is no logical flow in this diagram. Drilling should come first. And then after drilling, now you can have oil or no oil. And therefore, this should be avoided. And then now you can have now oil coming later. So this is now oil or no oil. And then also, because determining or getting oil or no oil is not within our discretion, then we normally use a circle. Where it's not within our discretion, we don't make a choice, we use a circle. But where we are making a decision, we can use now the box. Another thing should be avoided is mixture of decisions. If you're having two decisions, like now you're having decision concerning drilling, and that one concerning, let's say, obtaining information. This is now, let's say, surveying or hiring the expert. There is no way you would expect, you would mix these two decisions. For example, like you say, that we can either drill or survey. This is wrong. These are two different decisions. You cannot have them together. This is to be decided differently, this differently. Meaning, the opposite of drilling should be not to survey, but to not drill. The opposite of surveying is not to survey, but not to drill. Drilling is not the opposite of surveying, that's what I mean. And therefore, we should avoid such mixture of decisions, and you should have them separately. Like now here, you have this of drill, not drill, not drill. Then survey, not survey. That way now, those are two different decisions that are going to be done that way. But because they are going to be enjoined in a diagram, we need to know which one should come first, which one should be followed by, like that. Meaning, we need to reason also between surveying or hiring an expert to make a survey and advisors, and that one of drilling. You must need to have some logical sequence that it is the surveying that should come first. You obtain information first, so that now when you are deciding to drill, you are informed. But you cannot drill first, and then now you come and obtain information. For what? So we must have this kind of hints so that you can be able to have a good diagram. So like now in this question of ours, if you were to come up with just a sketch, just a simple sketch here, a sketch, we'll say that we must begin with the information concerning survey or not survey. Like now we can say hire the consultant or not hire the consultant, not. And if we hire the consultant, automatically the outcome of the consultation should be the report. That is the communication between you and the consultant. So this is the report. The report can either be favorable or unfavorable, which is not within our discretion. So we cannot be able to dictate how the survey or the report will be. Therefore, we use an event node, a circle. So we have here that this is the favorable, this is unfavorable report. Then it is when you receive the report that you make your own decision. When you have the report on the table now, you can continue making decision concerning should you drill for oil or not drill. This is now drill, and this is not drill. That if you decide to drill and you drill, you may come across oil or no oil. That is not within your discretion, and therefore it is with an event node. So you have here oil, and here we have no oil. And then if we do not drill, there is no way you would come and say here that oil or no oil. This is wrong because you do not drill, and we know obtaining oil must be by means of underground extraction. So therefore, you must drill maybe a well. So therefore, if you don't drill, then there's no outcome. There's no oil. It's just one simple outcome. That's the point. Now, if you have unfavorable report, then this one, there are some cases where it's not an open-ended question, but a closed-ended question, where you have been already given the solution of the advice that if the report shall be unfavorable, we shall not drill. If that is what we are told, then of course we just have one line. If that's what the question says. But our question does not talk of a particular report. Our question is actually giving us some leeway that even if the report is bad, you still have the right of making choice to drill for oil or not drill. That if you drill for oil, the outcome is either oil or no oil. If you don't drill for oil, if you don't drill, then of course you don't expect any other outcome apart from not having oil. That is actually the unfavorable report. And finally here, if for example you are not going to hire for consultation, then automatically you are going to make your own decision directly, and you are going to have considering drilling and not drilling. So therefore here we'll say drill, and when you drill you expect either oil or no oil. So this is oil, no oil. And if you don't drill, you don't expect any outcome. So therefore that's just one outcome here. Now one thing to note is that this is branch of hiring, the branch where you're obtaining information. So it carries with it all these branches and information. And this one is where you don't hire. Now again, it would be futile for you to indicate there is no hiring, but still want to indicate the information of favorable and unfavorable. That's only possible if you are hiring, because it is the consultant who is giving you that report. So this other branch here, when you don't hire, you do it alone, and on your way is where you do not have such kind of a report. You just make your decision directly and immediately. You don't need to wait. But here, before you make this decision, you'll realize that you have to wait for the information. And lastly, you also are going to realize that in most cases, it is this part. This part is the one, let me just circle it. This part is the one that we normally repeat always. This part is the one that we normally repeat. If you look at every branch or every decision, so here, that part, here, the same repeated part, here, the same repeated part. Is only where does it follow? Does it fall? Does it fall after the report? Does it fall without having the report because there's no consultation? So how do we draw it? Most importantly, where do we indicate a box? Where do we indicate a circle? That is the most important thing in a tree diagram, that you need to know when and where do you have the box, which is decision node, and where do we indicate the circle. And it must be clear that the diagram has a logical flow, that there is no an action or an activity that has been indicated to come last, but in actual sense should come first. Like where you have oil coming first, anything else happen later, which you know very well that oil should come last, because once you have oil, that's the end of the game. So that is the position. So this is very important, and drawing a sketch is also very important because it will give you a highlight of what is expected, so that now we can be able to draw the final draft. So this being our sketch, our final draft now will be as follows. So we need to draw the final draft from this sketch. A sketch enables you to have an up understanding about the question and how and the flow of a question. It is a lack of understanding of a question that you are unable to draw a good diagram. But when you understand the situation and the question, because some questions are not well elaborate, but it is out of making sense that you're able to know this step should come earlier, this step should come later, like that. Now this sketch, you can draw it this way now. We have the box. Then you have, this should be a circle, not a zero. A circle means you can record something inside, but a zero is you can't record something inside. Then you have this is higher. Then you have a favorable report and an unfavorable report. So this is a favorable. This is favorable. So when you have favorable, you make a decision to either drill or not. If you are to drill, you will get oil or no oil. If you don't drill, then of course don't expect any. So this is now oil, this is no oil, and this is not drill. So that is going to be our diagram. Then from there, we have the unfavorable. This is unfavorable. So this one will have also decision to make, that you're going to have drill for oil with the outcome being oil or no oil. Then you have, we may not drill. This is not drill. This is oil, this is no oil. Then we have the other side of not higher. We also have the decision to make here, decision, where we say we drill for oil. This is drill for oil. When you drill for oil, you get oil or no oil. This is oil, this is no oil. And if you don't drill for oil, then you don't make any profit there. So this is not drill. Then you can make sure that they end at the same position here. So this way. Same position. So you can share the same column. So this is a payoff. So I've labeled my diagram. Then something else note is that when you're labeling, where we have decision, remember after the decision node, we are having a decision. That decision alternative will be having its value either as a cost or as an income. For example, like you've been told, the cost of hiring or the cost of obtaining information is 3 million. So here we are going to get 3 million there. Here there is no cost for non-hire. This one where we have a box, drilling and not drilling, these are also decisions which we need to make, and we have some cost for them. Like for example, if you drill, you're told we are going to incur 10 million. So here we have 10 million. Here we have also 10 million for drilling. Here we have 10 million. So in case we are drilling, we are going to incur 10 million. If you're not drilling, there is no cost we are going to spend. And that's all about the decision. Then something else is now about the decision, no, the event node, where you have a circle. After a circle, we are having the outcomes, which are actually states of nature. And we require to indicate their probabilities. Where you have a circle, these are probabilistic in nature. Probabilities here, probabilities here. We do have such probabilities. The only probability we are having at the moment, which is clear, is as per the chief engineer. And from past record, from past information, or from past experience, that we have the estimate of 0.2 as the probability of oil. So that if you drill and to get oil, we have 20% or 0.2 chance. And this is 0.8 chance. But we have not yet obtained information concerning the same. That's why I've recorded them under this diagram or this branch of not hire. Should we hire and we obtain new information, we may end up changing our position. We may end up changing our estimates. And that calls for what we call revision of probabilities under what I gave here as the Bayes theorem. So we are going to use now what we call probability tree diagram in determining this revision of probabilities. So you can have this way. So this is a probability tree diagram where we'll indicate the way I had given you. We want the prior probability. We want the conditional probability, and we want the joint probabilities. That now we are able to understand every aspect. Now, prior is from our current experience and our estimate, our knowledge. We know that we may have oil or no oil with a probability of 0.2 and 0.8. That's why starting point. So this is going to be prior, that is probability of oil, which is 0.2, while probability of no oil, this is 0.8. That's what you have. Now, we were told in the question, the first hyphen, that if there is really oil, remember this company, we have used it before, so we know how they can give us, or we can estimate how they can give us their feedback. Like we are told there that the company estimates that if there is really oil, this company can give us, or these consultants can give us a report which is favorable, 95%. So if there is oil here, if there is really oil, the probability of them giving us favorable report, this is now probability of favorable report as long as there is oil. We were told it is 0.95. That's what we were given. Is a conditional probability. If there is oil here, then the favorable report will be 0.95. Meaning what? If there is still oil, there is a possibility of the consultants giving us unfavorable report, which is misleading in a way because there is oil, but they are giving us unfavorable report, meaning here. So you can have this one, and this one we can let it end at the end there. We say that this is probability of unfavorable report given there is oil. This must be the difference, which is 0.05. That gives us 100%. There is 95% of them giving us correct information when there is oil, and there is a 5% chance for them not giving us correct information. And we also told in the same question that if there is no oil, then there is a 10% chance of the report being favorable. So this is probability of favorable report giving us when there is no oil, which is true. As you can see, this branch is of no oil. It is 0.1. And therefore, if there is no oil, they can also give us the possibility of finding no oil, which is 0.9. So probability of unfavorable report given no oil, which is 0.9. This is the correct position, that if there is no oil, we should get unfavorable report. If there is oil, we should get a favorable report. So these are just errors that there is a 5% chance of them giving us a bad report concerning the position. There is also a 10% chance of them giving us a bad report concerning the position of no oil. Now, as you can see these branches, the way I've grouped them, the first branch here, you can see there is a common thing. The common thing is the report being favorable. So what we do is that we come and put here, this is a favorable. The other ones, they are common also. This is unfavorable report, unfavorable report. Therefore, I can have them here as probability of unfavorable report. So that now they can end at the same point. Now, we need to multiply. Now, 0.2 times 0.95 as now joint probability. So the two, when you multiply, you'll get 0.19. Yeah, 0.19 is the answer to 0.2 times 0.95. Then the other joint is 0.2 times 0.05. This should give us 0.01. In any case, it's even simple to know how to record this probability, because it is this 20% that we are trying to group it into two parts, 95% of it and 5% of it. So you can see these two figures. They should give us 20%, these two, 20%. Then we come to 0.8 times 0.1, that is, would be 0.08. While 0.8 times 0.9, this will give us 0.72. Again, it is this 80% that we are splitting into two, 10%, 90%. So these two should give us 80%. So that now, once we are grouped that way, we have now the chance and the opportunity of showing what we call the marginal probabilities down here. This is marginal probabilities. That now if you are to add the 19 and the 8, you'll get 27. So 0.27, that's probability of favorable report. And this is 0.1 and 73, you get 0.73. 0.1 and 72, you get 73. Now this is giving us 1. But one thing to note is that we can see that it is giving us the total probability of favorable, total probability of unfavorable. Now, when you come back to our tree diagram, you'll realize that we would require this probability of favorable and probability of unfavorable, these two. You write that you require these two. Now, you see that that favorable, there is no condition before it. Unlike this one, you see this one is oil, and this is also oil, but this oil is for the branch which is favorable. This oil is for the branch which is unfavorable. So that one is conditional. But the favorable and the unfavorable are not conditional at all. Therefore, we cannot pick this probability of favorable because this will be conditional. This is from the branch of oil. This 0.08 is also favorable, but from the branch of no oil. Those are conditional. So what we do is that we look at the total favorable, which is this one now, marginal. So this is 0.27, 0.73, we can record them here. So this is 0.27 for the favorable, now 0.73 for the unfavorable. That's how we can record the favorable and unfavorable probabilities. Then, when you come to this outcome, which is oil or no oil, it is clear that the first one here, it is oil, yes, but given the report is favorable. Because we have another oil, given the report is unfavorable. So what we do is, we can have them here, probability of oil, given the report is favorable, it is. As much as it is in the favorable branch, when it comes to the tree diagram, we use the favorable column. This is favorable column. Now we select, there are only two probabilities, and in this column, you select the one that is emanating from oil. The one coming from oil is this one, 19. So it is going to be 0.19 divided by 0.27. This will be 0.7 on average. While, so you come and record here, this is 0.7. While the probability of no oil, given the report is favorable, it is this way, probability of no oil, given the report is favorable. That tells you, you still go to the same column of favorable. Now you choose the one that is from no oil, which is 0.08. So 0.08, you divide by 0.27. This will give us 0.3 on average. Again, you come and record here 0.3. You should be having some knowledge that when you're having branches coming from an event node, their probabilities must equal to 1. That is the truth. Like now, we would have copied this 19 and the 8 there. But now, the two added together don't give us 100%. They only give us 27. So what do? We use them as our ratios. We say it's like saying 19 is to 8. 19 is to 8. By so doing, when we do the calculation this way, we find the proportions of 70 and 30%. They give us 100%. Now, the other one, the other pair, is the probability of oil given unfavorable report. So this one. So probability of oil given unfavorable report. That means we go to the unfavorable column, which is this last one here. We take the one that is from the oil, which is 0.01. So here, so 0.01 divided by 0.73. This will give us 0.01 as calculated, 0.01. While probability of no oil given unfavorable report, which is what we want here second, no oil given unfavorable, it is this one 0.72 divided by 0.73. This will be 0.99. So therefore, if you transfer these two here, you transfer them here, 0.01 and 0.99. Now you'll discover that yes, we have completed, and now we have the probabilities with us, and we can say that we have been advised accordingly. Now look at the impact. Look at how this revision of probabilities maybe is affected. Now initially, as per our past experience, the probability of oil, we believed there is oil only 20%. Somebody can say that maybe we were so pessimistic in a way, that there is only 20% chance of finding oil. But when you hire an expert who will come and give you a report, if the report is favorable, it confirms to you that there is oil. Now that you have known that somebody, an expert, has also proved that there is oil, your estimate, your confidence also goes up from 20% to a 70%. That is how the revision of probability is all about. That if you know you can do something and somebody gives you confidence that for sure you can do it, then of course the you are maybe let's say like the confidence you have goes up than the way it was before, because you are not sure. But this time somebody has confirmed that what you're doing is right, and therefore continue. So you get more encouraged, and therefore the probability go up. The same story here, that we thought and we expected that there is oil 20%. But since we have been given a favorable report showing that there is oil, our probability goes up to 70%. Now, secondly, if from our thought, we thought that there is oil 20%. Supposing we get a report showing us there is no oil, meaning unfavorable report telling us that there is no oil from the experts. Our previous estimate of 20% is going to be reduced because this time it has been confirmed by a third party that for sure there is no oil. So you cannot continue with your estimate of 20%. No. It has to go down because you have been discouraged, and therefore goes down to only 1%. This 1%. And the probability of no oil goes 29%. So you are likely to not drill if you're given this kind of a report. That if you have a particular maybe like a outfit that you like wearing, and somebody discourages you that outfit is not good, you are likely now not to wear it. That's what it means here. And if you have an maybe like an outfit that you do not wear so much, and somebody encourages you and tells you that outfit is nice, so of course you have a more likelihood of wearing that outfit. That's how the revision is all about. It's something which is nature, something which is normal in our lives. You keep on shifting goals or changing positions or changing the way of thinking because you now get more information with time. That's all about it. So I hope you have understood about the essence of a probability diagram in revising the probabilities. You see now here, I have not restricted myself to the exact formula for Bayes' theorem. I did not go back to the formula of Bayes' theorem because I have done a summary. But this way I told you that you take you take the four of them, you take this joint divided by the marginal. That's what I've done. So it's a summary of that I've done. Joint over marginal, joint over marginal, joint over marginal, like that. So I'm able to have my revision of probability. Now, we come back to the decision tree diagram. we want the outcome, the payoffs. The payoffs here meaning if you drill and you find oil, that oil you sell it, you'll get how much? You have been told the question that if you sell, will make 70 million. And if you do not find any oil, there is nothing you are going to sell, nothing to sell. If you don't drill, you do not have any oil. Therefore, there's nothing to sell also here. If there is oil, 70 million. If no oil and no drill, 0. If oil, 70 million. If no oil and no drill, 0. That is our situation there. Now, once you have recorded the payoffs, we now use what we call the rollback methods. From the right to the left. The known to the unknown, so that you can make a decision. Now, where we have a circle, when you have a circle, we are going to determine the outcome of the two branches, because you cannot avoid one branch, because it's not by your choice that you'll find oil or you'll find no oil. It is just by nature that it's probabilistic in nature that when you drill, you may find one of the two. But since you have not gone to that extent of drilling, then you're going to work with the two this way. 0.7 times 70 plus 0.3 times 0. So this when you multiply, this will be a 0, this will be 49. So automatically here we can say the expected outcome is 49 million. That is our expected value. Instead of dealing with the 70 million like in Maximax, if these two are our values, then the Maximax will take 70, but the Maximin will take the 0. So in this case, we are using an average which is 49. Same case here, that 0.01 times 70 plus 0.99 times 0, this will be a 0, this will be a 0.7. This is a 0.7. A 0.7. Then down here, we have a 0.2 times 70 plus 0.8 times 0. This one gives us a 0, but this one gives us 14. So this is going to be 14. So I have managed to determine my expected values with respect to those outcomes, since they are probabilistic in nature and we are not the one choosing or either making a decision on them. Then we go backward a bit now. When I go backward here, I am having a box. A box means I make a choice. I compare the two and I make a choice. For example, if I compare here, drill, you'll incur 10 million, but you'll make 49 million. Of course, you'll make a net of 39 million. But if you don't drill, you make a 0. Of course, you'd rather drill. So you indicate that the decision here, drill. We drill here and we make that 9 million as the profit. That is our decision. We drill so that you can make the profit of that 9 million. Down here, if we drill, we'll make 0.7 minus 10. It's going to be a loss of almost 9 million, no, not more than 9 million, that is. But if you don't drill, we'll not make a loss. You better not drill because you'll not be incurring any loss. But if you drill, you'll be committing so much money for nothing. And therefore here, not drill. Not drill. So that you can make a 0 here. A 0. Nothing to make there. Here, if we drill, we make a net profit of 4 million. 4 million net profit. But if you don't drill, we make 0. You'd rather drill. So here we are going to drill. We are going to drill so that you can make the 4 million profit. Then finally, there is this expected value, meaning you have to work with the two at the same time, the favorable and the unfavorable. So this will be the 0.27 times the outcome, which is at 9, plus 0.73 times the outcome, which is 0. So this one will give us a 0 when you multiply. But this one you multiply will give you 10.53. 10.53. That is going to be our expected outcome. 0.27 times that 9 million. Now finally, we come to this where we started. where we compare. There's a box. Being a box, we compare, we make a choice. That if we hire, we are going to make 10 million, 0.53, but we are going to incur 3 million. So you'll make a net profit of 7.53. But if we do not hire, we'll only make 4 million with no cost here. So 4 million and 7 million, you can tell that the 7 is more. So therefore, we come and indicate here, we better hire. We better hire the consultants, and we make a profit of 7.53 million. That become our solution. 7.453 is our solution. So that means in that requirement, this was requirement number A. So we say here that the company should hire the consultants and drill for oil should the report be favorable. Look at that. That we are making this decision that the firm should hire, but again, they should come and drill here, as long as the report is what? Favorable. Otherwise, it is known. If the report is unfavorable, we shall not drill. But if the report is favorable, then of course we shall drill, and that is the position. So we can make that. So the expected value is 7.53. That's the point. Then part B, lastly, you are asked to determine the value of perfect information. So if I have it here, value of perfect information. So this is part B. It's asking us value of perfect information, which you have been saying these many times. So this one is expected value with perfect information minus expected value without perfect information. It happens that when you are doing it using a tree diagram, these denotes branches. The expected value with perfect information is this branch that you are already hiring the expert to give information. And therefore, you just substitute. The amount of money we are making when we hire the expert should be before we pay the expert, meaning it is 10. This is what you are getting from this branch, 10.53. It should be before we pay the cost. Otherwise, it will not give us correct information if we take 7 point, we take 10 point. Then the expected value without the perfect information is this other branch where we don't hire the experts. Here we have no information, but we are making how much? 4 million. So this is 4 million. Now what does it mean? It means the value of perfect information is shillings 6.53 million. The value of perfect information is 6.53 million. Remember, this is even now higher than, if we were to compare, it's higher than the cost. The cost we're being charged by the consultants is 3 million. As long as the value is more than the cost, we are good to go. But when the cost will be higher than, then of course we would not actually accept the same. Now that's how we need to compare. Now we have answered as per the question, part A and part B. Just an assumption. Supposing the cost of information was not 3. Suppose the cost of information maybe was like, say, maybe was an amount of what? An amount of 10 million. 10 million. Or either this being 6 million. If we add it to that cost of hiring, let's make it 7 million. Assuming that the cost of hiring was 7 million, let's have it 7M is the cost of hiring. Automatically, this would not have been the best. Because this would have meant it is 10.5 minus 7. That means the value would have been 3 points. So suppose this one was 3.53. That would have been our value. while this one is 4 million. That means we would have said that the company should not hire and they drill for oil. So to get 4 million instead of 3.53. But now, if you get a proposal from these consultants that you'd get a discount to enable you change the decision, because currently this is the best decision assuming, so you would get a discount from them so that you can change your decision and you award them the contract of surveying, and to you becomes also the best decision. Of course, since this is 4 million, you'd want to make more money here from 4M and above. The amount of money that you are making lesser than 4 million is the difference here, which is this is 470,000. So this is now what you get. So 470,000 would have been the amount. This now should be the discount. If they give you the discount of 470,000, the higher the discount, the lesser the cost, and therefore the higher the profit. If we get a discount of 470, we are going to make profit of 4 million. If this one you add to, you get 4 million. That means this being our discount expected from these experts, and assuming that the cost to Mesema is 7 million, then automatically you would require to determine the percentage, the discount percentage. So you will say it is actually 470,000 divided by 7 million multiplied by 100. The discount that you expect them to give you should be 470,000 divided by 7 million times 100. This would actually be 6.7%. 6.7%. What does it mean? It means that if the consultants would offer you a discount of above 6.7% of their cost, then of course we are going to change our decision. We shall give them that contract. They come and do survey for us, and that would be the best for us instead of this one. So sometimes we normally look at that you can have this decision better than this one, but if you're offered a discount, you may change your decision. So that's something that you need to know as a manager, because there must be that kind of comparison, that consideration. Is it. So that's all about the decision trees, about the revision of probabilities, using the Bayes theorem, using the probability tree diagram, and that is all about the lesson 3. And that again has brought us to the end of decision making and both uncertainty and risk. And we have expounded risk to the end. So we only left now with decision making and competition, which is game theory. So our next lesson, lesson 4, we are going to feature the game theory. So we meet in the when you do game theory. For now, thank you, and please practice more.